All right, Crewton Ramone's House of Math, fooling around with some. I guess we're gonna do fractions, right? Let me turn my speaker up. There you go.
Remember, before we start the video, to like and subscribe.
There you go. Like and subscribe. Yes. All right. So excellent. So you were pretty excellent with fractions last I recall. So let's fool around with a few of these. Remember improper fractions?
Yes, I do.
All right, let's see if you can. What's the deal with improper fractions? Well, the deal with improper fractions. Let me just.
Wait. Pause this video.
What?
And think what improper fractions are.
What are improper fractions?
Now, unpause.
Okay, what are improper fractions?
Okay, improper fractions are fractions that has a numerator bigger than the denominator.
Excellent. So, that is exactly correct. All right, so let's do it. Let's convert some improper fractions to mixed numbers. What do you say?
Yeah.
All right, you can knock them out. Watch her knock them out. I'll bet you can. How about that one?
Oh, Ben.
Oh, what?
It's Shredder's birthday today.
Whose?
Shredder's.
Oh, Shredder turned what? 1?
1, yeah.
Wow. I remember when you first got Shredder.
Okay, 10/3.
So.
People are watching.
Are you going to throw Shredder a party? That way you get the harness on and stuff?
Okay, how many times does 3 go into 10?
Yes.
Right. 3 times.
3 times.
But there's a remainder. So it goes in 3 times 3 is 9. Mm-hmm. There's a remainder of 1. So 1 should be 1. It's 1 get over 3.
There you go. 3 1/3.
That's how you do it.
Yeah, that's how you do it. Excellent. Came with it. Excellent. All right, and what are we doing? We're counting how many of these are contained in there. What we're really saying is there's one. Really? Wow. I gotta get the glue
It's
gun.
really simple, guys.
It really is. 1, 2, 3, and 1/3 of 1. That's really what we're doing, right?
Yeah.
So we're counting that. Look, we've got.
You basically see how the biggest part, the hardest part, is to see how many times 3 goes into 10.
Right.
For this problem.
Yes.
It's the hardest part.
There you go. All right. So now, if I have a problem like this and I want to convert it into a mixed number, let's say I had something like, just to give you something to do, let's say I had 7 and 5/8. What would be the improper fraction?
So, what you do to find the improper fraction, so you times 7 by, you times 7 by 8.
Yeah, 8 times 7. We're going to go this way.
8 times 7, which is 56, plus 5.
Right, which is...
50 plus 5 is 61.
Excellent.
61 over 8.
There you go, that's what we're counting by. Wow, look at you. You got these wired, no problem. Know what to do. You can do any of them, right?
Yeah.
All right, now that's the thing. Once you can do one of them, you can do any of them. And we're not even going to spend time on it because you'll get bored. All right, how about we add a couple fractions? Okay, so this one you might need your paper and pencil.
Okay.
Just because you got to keep track, right? You got to remember all the different things you got to do. So let's just take something similar, like 2 1/3 plus 3. And actually, you know what? We'll make this 2/3, just so we have an extra. The fraction turns into. And then we'll do this one as 2/3 and 5/8 for sure. We're gonna have that. All right, add them up.
All right.
So I have like say, I don't know. Can we make up a story? You want to make up a story?
These are really annoying because they're easy. It's just like you need to write it down.
Right, and there's a lot to do, right? But you're right. Once you see, that's a complete change of attitude right there, miss. Right? Because all it is you're right. It's tedious. You have to do all this stuff. All right. So anyway, add them up. Now we can do. Which way are you going to do it? Because we can do it 2 ways, right? We can do it where I add the 2 plus the 3, and then I add the 2/3 plus the 5/8. Or
Yeah,
I can turn them into improper fractions and then find a common denominator and then add those and do all the division. I don't know. Anyway, however you want to do it.
No. That's way too complicated.
I agree.
Okay.
See, because I could just as easily do 6, 8 over 3 plus 24, 29 over 8, and then I got to make common denominators, right? So I'm going to multiply this one by, and there's nothing in between. Right? Can't do 16, can't do that. The lowest one we could do is 24. So this has to go 8 over 8, and this has to be 3 over 3. Wow, what a lot of work that is. How about we just do it easier?
Yeah.
So I'm going to add this and this, and then I'm going to add this and this.
What can 3 and 8 go into?
I just did it.
Wait. Yeah, 5.
Wait a minute, 5? What?
Wait.
3, 6, 9, 12, 15, 18, 21, 24. Ooh, 8, 16,
Okay.
24.
24. So
Yeah.
the denominator must be 24.
Alright.
I thought you meant to did the whole problem.
Alright. So you got to be 24s. You're right. I'll take the 24s. How many 24s over here? Well, 16 24s, right?
Correct. Wait. I'm checking. Just checking. Because sometimes.
Oh, 2 8s and 3 8s. I like it though. See, she doesn't trust me. And that's the way it should be.
Yeah, that's true. It's true.
Alright. Alright, now over here I got to do 8s. So I got 3 8s, right? I multiplied by 3. And over here I'm going to have, or excuse me, 8 3s. And over here I'm going to have 5 3s. Which is the same thing as 5 8s. Now we can add them together. Right? Now we can add them together. That's easy. So we play blocks. This is why we.
Basically, everybody who's watching this video, basically just add the numbers on the top and don't worry about the bottom.
Right, because this is the 16 of the 24th kind and 15 of the 24th kind, so we don't have to worry about the 24th kind. So we just got to get these guys together. So we know
and your final answer is 31 over 24.
All right, so now I've got 2 plus 3. We did this part. I got the 2 plus 3 is 5 plus 31 over 24. Well, we can't do that because that's improper. So what do I have when I get my improper fraction over here?
Well.
How many 24s and 31? See all the math we're doing?
Yeah.
And you can do it all in your head. That's the cool part.
Okay, 1.
Okay, so 1. So we're gonna call this. We're gonna call this 6 because there's 1 in there. And how many's left over?
1 and 7/24.
Bam.
Okay, done.
So
done.
wait a minute, but then we had to add the 1 and 7/24 to the 5 to get 6 and 7/24.
Okay. 6 and 7/24.
Got it?
Yeah.
Okay, the only reason why I did that one is so that you'd have to do this, so that you'd have to add the 1. It's not 5 and 7/24, right? It's 6 and 7/24. Wow, look at you and your fraction skills. Okay, no issue. Oh, got the string cheese. Gotta like the string cheese. Okay, how about... Well, now it's just super easy. Let's do some simple stuff like, let's get complicated fractions going, and then let's get into some algebraic fractions, where we play find the one. Let's see here. Let's get a complicated fraction. Let's say I want to know 2/3 divided by 1/2.
2/3 divided by 1/2.
How many halves are contained in 2/3? You know what to do?
No.
Well, what we're basically saying is, there's another way to look at this, so we're going to do a half and 2/3. How many halves are contained in 2/3? Well, see, now this is the problem. Problem is we can't count these because they're not same. I can't count halves out of thirds. Can I? So I gotta make them same. Can I make them same? I make them same. By making them same, I mean make the same kind, the same common denominator.
Well, yeah. Right?
Yeah.
12. Wait, no, 6. 6, sorry.
Alright, I'll go with 6.
Wait, where are you right now?
I'm in my house. Why?
Coronavirus.
Coronavirus. I'm not too terribly worried about the coronavirus because I've got a good immune system, but the idea being is, yeah, that could be problematic for some people. And it's definitely not I thought it was just going to be a silly thing, but it looks like you actually might have to pay attention a little bit.
Okay. Yeah.
But between your dad and all his stuff, you'll be fine.
Yeah. Everybody, next step.
Alright, so what do you got to do? What do you got to do? So we got this.
Now, what you do is you see how many times the denominator is. So the denominator for the one outside of the box is 2.
Mm-hmm.
2 is created. If you get what I mean. Outside of the box. Okay. Now, the next one is 6. Wait, no, not 6. Sorry.
Alright, hold on, let me kill some of this. Where'd you go? Where are you? There you are. Alright, there it is. Okay. So 6. So what's this gotta be? This is gonna be 3, 6, right?
Yeah.
Well, what's this gonna be?
That is gonna be 2, 2.
Well, how did I get to 6? What did I multiply this by to get 6?
Oh, 4.
Yeah. There you go. So now it's just 3/4, right?
Mm-hmm.
Because what I'm saying is, how many 3s are contained in 4? Right? So I'm going to show you this in a second. How many 3s are contained in 4? 1! And how much is left over?
And wait, what do you mean? Oh.
Well, I counted out 1, right, in there.
1 left over.
So let's just get rid of all this. We'll get rid of this part. And we'll say there's 1. That leaves 3. That means there's 1 left over. What were we counting by?
1 is left over.
Right. So what were we counting by? Since we get to stay in fractions.
We're counting by 3s.
There you go. So 1 1/3. Let's see if that's right. Right? Because that's that 1 1/3. See, this is what I mean with it. All right. So let's see here. There's this whole other thing where I take that same problem, and I was saying 2/3, and I want to divide it by 1/2. Right? Well, I want to find out how many. So there's this thing about invert and multiply, where what am I gonna wind up with? I'm gonna wind up with 2/3, right? No, except 2/1. I got ahead of myself, right? And then that's just the same thing as 4/3. Look familiar? And then we just had a second ago, and we did this when we decided that we had to make them same.
Oh yeah.
And we had 3 and 4 and 6 and 6. So all it does is see that invert and multiply thing. It just gives you a quick shortcut.
Yeah.
Right? So I don't have to do all of this. I can just invert and multiply, and I'm done.
The hard way.
Yeah, I know exactly. Why do it the hard way? Because dude, we're done. That's it. 3, 4. There it is. 4 divided by 3. And so this is what's confusing a lot of children, is because this is 3 contained in 4 times. That's what they said. How many 3s are contained in 4? So they get confused which one goes where. Outside of the box or inside of the box, as you said, right?
Yeah.
Alright, let's do another one where you do it fast and easy. What if I did the other way around? And I had 1/2 divided by 2/3. So now, what do I have? I have this. I'm saying, let's see, it's 2/3 over here and 1/2 over here. Oops, and 1/2 over here. So how many 2/3 are contained in 1/2? Well, can we do the same thing? Make them 6. If I make this 6, this is 3. And if I make this 6, this is 4.
So it's going to be... Don't. I have an... And it's really annoying. Okay. So.
And see, the other thing I can do is that's what that is. The other thing I just invert and multiply. So I wind up with 3 over and I get 3/4. And isn't that even just what that says? That says 3/4. That says how many 4s are contained in 3? I mean, there it is.
3/4. Oh, that makes sense.
Yeah. I would hope.
Well,
let's get rid of all this.
Way too.
Let's put a dot right there, and let's put an equal sign right there. Now we're all happy.
Okay, then it will be 3/4.
Right? Because that isn't. That's exactly what that says. It's not even a whole one. There's not there's none in there, right?
Hey Ben, I'll be right back. I just need to get some.
Okay, go ahead.
Shredder.
We
Stay there.
But you're gonna put.
Ben was watching you.
All right. Shredder likes to look at the computer screen, so it'll be okay.
He's watching you.
Wow, I can't believe how big he's gotten bigger and bigger and bigger. Or she is. 1
Can
year.
you see her?
How old is she supposed to live to?
She's 1.
I know, but how old is she supposed to get? Because it looks like she's gonna get bigger.
Yeah, I don't know. It's the gray one. Okay. Was she good?
She didn't do anything. She didn't even move. Alrighty. Aphrodite. Oh, wait. And then multiplication is super easy. In fact, that's what we're doing. So that's why I skipped the multiplication and go directly to division, because you got to do multiplication to do division, right? All right. Let's do some other kind of fractions. Let's do some algebraic fractions. So let's say I have what kind of algebraic fraction? Let's do a find the ones kind. Let's say I have 3. We're just gonna play find the ones. 3x squared plus 2.
Wait, can we literally play What's Under the Cup?
Well, we're playing find the ones. What's under the cup is when we do problem solving. But I'm gonna do, like, say, we'll call this 3, and we'll make this 8 for fun, and we'll make this bigger. We'll make this 9, and then we'll make this we'll make this 4, and then we'll make this 3x squared and 2y. There you go. Can you reduce that? Have you got your whiteboard?
No, I don't.
Oh well. Well, then use a pencil and paper. Because here's what we're going to do. This is easy. How many 3's are in 9? Actually, you know what I'm going to do? I'm going to write this another way. I'm going to write this...
Oh, just 3.
Yeah, just 3. Okay, so there's 3. Now, actually, you know what? Before we even do that, let's do this. I have x times x times x times x and a 9. That's what that says. And then over here I have 3 times x. Do you see some ones? You see
what?
the 1? See the 1?
I do see the ones.
Alright, so now, is 9 divided by 3 hard?
No.
What do you got?
9 divided by 3 is 3.
There you go. So this would be just 3x squared, that part. Now over here, I said I had 8 y times y times y over 2y. Do you see any ones?
No.
I do. What's y over y? There's 1.
Y over y is 1. Oh, 1. Yeah.
Yep, there you go. So now there's my 1 that I found. How many 2's in 8?
Yeah.
How many 2's in 8?
4.
Done. Right? Now, I get rid of that. And am I going to write y times, heck no, I'm just going to write y squared. Yep, exactly. Why would I write y times y? Done. So this whole thing turns into this thing. All I did was find the 1's. I reduced this complicated looking fraction to this thing.
Yeah. Oh! Whoa.
Alright, so let's play some more find the 1's. Because like here, look, actually let's take a step backwards. If I have x times x times x over x, well, isn't that just the same thing as saying x to the third over x?
Yeah.
Alright, do you see a 1 in there? Can you find a 1?
Oh my god, you made it so simpler. Wait, can you do another one?
Yeah, no, well, tell me this one before we get crazy. Can you find a 1 here?
Yeah.
Where is it? Right, can you see the 1? Wait, I'll use a different pen. I'll use black, sure, why not? Do you see my 1 right there?
Yeah.
So now how many x do I have up here? Well, then I have x times x over 1, which just means x squared. I love it. Duh. Now, here's the other thing we can look at. We can draw a picture of this.
Oh god.
Alright, oh, what? Oh, God. You need the pictures. So, let me get a green pen. There's a green pen. This is my... I know, what is she doing?
She's like going behind me and like, Dad, is he in there? Cool. Okay.
Oh, what's the weather like over there?
Snowy.
It's still snowing?
Yeah.
It's snowing over here too. Well, it's not snowing on Maui, but on the Big Island it was snowing to the point where they were actually skiing on Mauna Kea. Because there was a lot of snow.
Can we do math?
Yeah. Alright. You're pretty funny. Anyway, so, what do we got?
Oh wait, can I have it? Okay.
You get more string cheese. So there's my x to the third.
That looks like a rectangle. What is that?
It is a rectangle. It's my x to the third.
Okay. Dad, can you put on clear and focus? Yeah, I will.
Oh yeah, good idea.
Was it cold?
Turn it up.
Ben, you're looking at me like you.
Well, I know. I'm trying to figure out what the heck he's putting on your wrist there. What is that?
So look up Apollo Neuro. I met some of the guys that actually came up with this thing.
Mm-hmm.
Pretty cool technology. So Apollo Neuro is what it is. Look it up.
What? Spell it. Palo Nero?
Apollo, like the
god.
Oh, yeah. Careful, you don't switch.
Apollo Nero?
Yeah, ApolloNeuro.com.
Oh, neuro. So it's some kind of nanotechnology device?
No, it's like basically, you're familiar with like sympathetic, parasympathetic, like stress modes and stuff like that.
Sure.
So basically, this is like the idea that like touch.
Just hold on a second,
It's basically like it uses sound or vibration to basically activate your parasympathetic
nervous system.
So like if you're, so it helps you basically get out of fight or flight, which a lot of people are in. So
yes, especially when it comes to and also especially when it comes to mathematics. Oh, I got to look this up for sure because I have plenty of students that as soon as they're exposed to some math, they immediately go into fight or flight. All right, thanks. I'll check it out. All right, back to math, young lady. So here's what we have. Do you see that I have? Look, I'm just saying. I just drew a picture of one of these.
Whoa.
Right?
Yeah.
So that's the x to the third. There's my x. So can you see that this is all the same? So now what do I have? Well, tell me the dimensions of this, by the way. This is an x to the third. That's just an x squared. Or excuse me, that's just an x, not even an x squared. Right?
Yeah.
Alright, now. So the dimensions of this are x. You tell me, what are the dimensions of that? X by what?
X by what?
Yeah, what? This has to be x across. How long is this? What times x is going to give me x to the third? Which is a big question for a little girl.
3.
Well, hold on a second. X times 3 is just 3x. I need an exponent.
I don't know what you mean.
That's what I mean. See, that's why we're going from fraction there. All right. So this one is, I'm just going to tell you that this one is, well, actually, I'm not going to just tell you. I'm going to do this. What if I have 2 times 2? Right? Isn't that a 2 square?
Oh, 2 times 4 is 2 is 4.
Right, so 2 times 2, that's just 4, right? Do you see them there? 4?
But 2 to the third.
Now, wait a minute. Yeah, 2 to the third. There you go. What's 2 to the third?
8.
There you go. And what did I do? I said 2 to the third is 8, and you're absolutely correct. And what I said here is that, look, I've got 2 squared 2 times. And that whole thing is going to be, 2 to the third. Now watch. I'm going to make it. Do you see it? There it is. There's my 2 square. By 2, that gives me 8. Now, I could just as easily pile them up and say that it's 2 times 2 times 2. What shape is this? If I do that?
That's a cube.
That's a cube. That's why we say it a cube. Yeah, I love that. Oh, that's why we call it a cube. But look, I just made my cube flat. So instead of having it like this, I did it like this instead of piling them on top of each other. See that? Pretty simple. Let's do it. Wait. Let's do it again. Have you got some blocks? Get some blocks handy. And build me. Well, good. Then build me a 3 cube.
A 3 cube.
A 3 cube. Yeah. Now you could grab a whole bunch of 3s, right?
Okay.
Yeah, build me a 3 cube. A 3 cube.
Okay.
So there's that. Right? So that's my 3 square. Then you're going to have to build a cube. So you're going to have to take some more and put them on top, right? And I'm not going to...
I'm making a 3
cube.
cube.
Yes, you are.
Oh, a 3 cube.
Yeah, 3 by 3 by 3. There's 2 layers. Well, here's mine. So far I got 2 layers. And I need 1 more layer.
Okay.
And these are magnetic.
How? Shredder, how did you fit?
Alright, there's my... Build your 3 cube.
What?
I said build your 3 cube.
I am.
Okay. Let's see it. There's mine. And it really is a cube. I mean, if you build them across... Yeah, see? There's mine one. Right,
Yeah,
oops,
yeah.
there you go. Can you build yours?
I'm almost done.
When did you get that thing? That thing looks cool.
Dad got it.
Do you notice? Do you notice a difference when you wear it?
I do.
You really do?
Really do.
Excellent. That sounds pretty fun, actually. I will look into that for sure.
It's like, I know.
Now, here's the thing. You got your cube? Tilt your camera down just a little bit, and I'll take a picture of it.
And I'm not done yet.
Okay. Still, but tilt your... There you go. Almost. There you go. Now, that's the thing. Exactly. Do it across like that. So the first ones go like that. The second ones go... There you go. Like that. Excellent. And what's Shredder doing?
She's behind me. She's
All right,
like
there you go. There's the first. There's 1 more layer. Now turn on the other. Yeah, there you go. Perfect.
I don't like pink.
You don't like pink?
Yeah.
What color do you like?
Also, pink reminds
All right, just
me of
stick it
three.
together. Make it look good. There you go. All right.
And
So now, how many in your 3 cube? Miss, how many in your 3 cube?
how many what?
How many in your 3
Nine.
cube?
9.
Wait a second. If you can count 9 there, there's a whole lot more than 9 there.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, 9 threes.
Well, what do you mean? Oh, 9 ones.
Yes, so it's not just 9 ones, it's 9 threes.
6, 9. Okay,
Well, what's 9 times 3? You're going to count them one at a time?
Alright, 9 times 3 is 27.
Done! That's your 3 cube, right?
Yeah.
Okay, now take your 3 cube and spread it out next to each other. Yeah. Make it all one layer, you know what I mean?
Okay. I know what you mean, I think.
There you go, and then put another one right there. There you go. Alright, watch me, I'm gonna cheat. Bam! Isn't it the same?
Yeah, wait, am I doing good so far?
Yeah, you're doing great. What do you mean?
Did you hear that, Mom? Thank you.
Crack me up. Anyway, but you see, I just grabbed 3 9s because I'm lazy and I'm a cheater. But there's your cube laid out, right? Now, do you see that this side is 3 times 3? Is that's a 3 square, and that's a 3. There you go. See? So look, I just said x squared times x is x to the third. What we said over here is that 3 squared, which turns out to be the same thing as 9, times 3 is the same thing as 27. There's my cube. But it doesn't look like a cube because you flattened it out. So instead of having 3 dimensions, we just have 2 dimensions. This side and that side. Does that make sense?
Yeah.
Alright. And I could do the same thing with 4. And I could do the same thing, right? Okay. Now, so what I did a second ago when we were playing Find the Ones is I said, look, if that's x to the third, this side must be what?
X to the, third.
Wait a minute. That's the whole thing. What's the one side?
Oh, x to the...
What power?
1.
Well, if it was x times x, I just have an x squared. So what does it have to be?
2.
Yes, it's got to be 2. Ooh. So see what we do with the exponents? Oh, there's a lesson all by itself. And she's, oh, I can see the wheels turning in your head. Literally can see them turning. All right, so that's the idea. Is look.
I'm creepy, but okay.
All right. So look, all I'm saying is that this is a 3 square times 3, and the whole thing is 3 to the third, which is 27. Oh man, let's make those nice. 3 to the third. There you go. Make sense? So now this is just in general. X squared times x is x to the third. 3 to the second times 3 is 3 to the third. And I could do 4. Let's do 4 just for fun. Just for exercising your brain.
4 to the 4.
4.
Wait,
So
okay,
what's 4 squared?
4.
Yep, there you go. But what's 4 squared?
4 squared is 16.
All right, so get out 16.
Wait.
Not that one, the 16. 10 and a 6, 10 and a 6. Or you could use your 3s that you already have out. Yeah, just 10 and a 6. All right, put it down there. Flat on your table. Well, not like that. Like this.
Oh, okay.
There you go. Now, that's 4 squared. How many of them do we need?
4 squared. We need.
If I want 4 to the third. How many of them do I need? So look, you see I've got 4 squared here? Or excuse me.
12?
I got, yeah. Wait a minute. How many do I need? I need 4 of them. Don't I?
Yeah.
So get out 4 of them. Well, duh. There you go. Fine. So, you funny. Now, if you want to use that 40 block, you can.
Yeah, that's what I was gonna do.
There you go. Just get the 40 block. Get that 10 out of there, and then you need it 4 times. So here's my 4 6s, and my 40 block. Where's my 40 block? Well, I got a 40 block. I got no 40 block. There it is.
You have no 40.
I have no 40 block. I need a 40 block. There you go. Yeah, there you go. Yours looks great. Yes, yes. There it is. There you have it. So look, there it is. I have a 40 block where I have 16 4 times, and that's 4 to the. Okay, so what? How much is that?
How much what?
How much is it total if I was counting all of the units in there?
Whoa, slow down.
Oh, come on, what's 16 4 times? You can do it.
40.
40 and 24.
Yeah.
Where's the...
Because 4 times 10 is 40, and then 4 times 6 is 24. So,
yeah, look at me being dyslexic. There you go. So what do I have?
You have... What?
Just add them together. It's how easy is that. What's 4 and 2?
Okay, I thought you meant something else. 64.
There you go, done.
Wait,
So can you see that 4, not at this rate, at 4...
What do you mean?
I mean, we got too much, we got more ground to cover. And, it's only 1:45. We got 15 more minutes at least. And I got to run anyway because I got a class right after this, and it's not here at my house. I got this dyslexic kid that I'm playing with, and he's having a great time. He was like you when he first started out. He was not very happy, and then now after about 5 lessons, he's like he wants to come to class because he's learning math and he knows that it's I make it easy for him.
Yeah.
Just like you. Are you not now like acing your fractions and stuff like that in school?
That's easy.
Yep. See.
But they just make it way more complicated than they need.
There you have it. That's my youngest boy says it all the time. If you can do this, the stupidest way is the way they do it. Right? The most long and ridiculous algorithms are the ones that they use. If you have a shortcut or something easy, nah, they don't want to teach you that. Anyway, all right. So look, we've got 4. So you see again that it's just if I had x squared times x, I get x to the 3rd. Because isn't 64 the exact same thing as 4 cubed?
Yeah.
That is the same, that's the same number right there. That's just 2 ways of writing it.
Uh-huh.
Are you good? All right.
Good.
I got a big fat thumbs up. I like it. Alrighty, so look, now let's get back to this lesson where we're playing Find the Ones. But you got to play a little bit first. So now I have, do you see? I'm just going to look at this. This is, what's the dimensions of this? This is x by 1, right?
Yeah.
So here's what I'm going to do. Dun, 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 dun. Do I have one? Yes, I do. I just need an old envelope. Any old envelope will do. I'm going to just do this. And just look at that. What do I have? I have x squared over 1 over 1, which is, there you go. So when I have x to the 3rd over x, that's just x squared.
Literally over.
You see it?
Yeah.
And technically I could write it correctly, that it's x squared over 1. Because what am I doing? I'm just looking at this one factor. I just quit looking at the whole thing and I just look at the one side.
Oh, I get it. Okay, can I do another one really quick?
Yeah, definitely. Especially now we're on a roll. Hell yeah.
Wait,
all right,
wait a minute.
What if I did this? Give me a red one.
I just want to see something. I just
All
want
right. Let's see. What if I did this? What if I did this?
Think you might be away.
All right.
Okay, but give me one like the other problem.
Yeah. I'm giving you one just like it, except I just changed the numbers a little bit. X to the 3rd. I will. We'll get there. Over x squared.
Okay, it equals x over 2 over...
Wait a minute. Wait. You got to say it right. X squared.
X squared over x.
There you go. Done. Look at you. Look at you.
Yeah.
It's just x squared over x. Now wait a second. I can reduce that further. So let's do that. Let's do that. I've got x squared over x. Now what do I have? Zook.
X squared over x.
X squared over, ooh, is that an x or just a 1?
X squared over 1.
I like it. All right, now, look. Here, we'll do the shortcut. See, because we had to do it twice on this one, right? So I have x over 1, which is what that is. X over 1. Did I stay on the board? Can you see this? Yes, you can. All right, barely. All right, so, look. Here's a faster, easier way to do it. We're going to play find the ones instead. Let's do, what we're saying here is I have x to the third, which is x times x times x, over x squared, over x times x. Well, can you see that I can just go directly to, there's a 1, there's a 1, x over 1.
Exactement.
I like it. How's your French going?
The Spanish.
Yeah, do you like, are you doing French or are you doing French and Spanish?
Both.
Both. Which one do you like better, French or Spanish?
Spanish.
Me too. I like Spanish because it's easier and it's much easier to pronounce. But yeah, I think you're gonna be. I think you're gonna be happy later on when you get older. You're definitely gonna be happy with.
Biblioteca.
Yeah, there you go. So, are you going to the library later?
I don't like books.
What? That exactly. That's not true. That can't be true.
Tell me about it.
Are you kidding? You got. Anyway, I've seen you spend lots of time in the library just looking at books.
Yeah, I was probably looking for my computer or something. I don't know.
I don't know anybody smart that doesn't like books. I mean, seriously, everybody I know that's smart loves books. All right, let's get into more of this. Are you ready? Are you ready? Are you ready to get crazy?
Yeah.
All right. Let's get big. I know we've only got a few minutes. We'll go 5 more minutes and then we'll quit.
Okay.
Okay. So what if I had x to the 5th y third over x squared y? So no negative exponents at the moment. So let's just rewrite this. Take your pencil and paper and just write this. What I'm going to have is x times x times x times x times x. That's what that says. 1, 2, 3, 4, 5 of them because we're lazy. We're not going to write them out like this, but we're going to do this just for fun to play find the ones. And then I've got y times y times y. And then over here I've got x times x. And then I got 1y. Can you play find the ones? Do you see the ones?
I see the ones.
All right, write them down on yours. Write them down on your piece of paper. There's a 1, there's a 1, and there's a 1. We're playing find the ones. Because over here they're not easy to see, but over here now they're super easy to see. So what do I have?
You have
How many up here?
3.
Uh-huh, so am I just gonna, is that 3x or is that x times x times x?
3x.
Oh, try again then.
X times x times x.
Okay, yes, you only had 2 options. So that gives me x times x times x is x to the 3rd. What's y times y?
Y times y. Y. 1.
Wait a minute, 1? How many of them are there?
Y squared.
There you have it. I like it. She thinks for a moment. Y squared. You are correct. Now under here it's just 1. That's a 1. That's a 1. That's a 1. So 1 times 1 times 1 is 1. Just 1. Why even write it? Do you see what I did?
Exact.
All right. So here I'm gonna write this more nice. I'm gonna write this nicely so it's big. I'm just going to have x, these guys, 1, 2, 3, right? Multiply them. And these are exponents. We're not multiplying 3x, right? We're multiplying x times x times x. And over here, we're multiplying y times y. So over here, we have this big, long rectangle shape. And over here, we have this square shape. Yes, I know. I like it. I like it when it makes sense.
You can spin the denominator and cross it out, and then do that times, yeah. Okay.
All right. See, look, we're playing around with algebraic fractions now.
Yeah.
See, because what they do in school is like, oh, you're just a little girl. You can't do algebraic fractions. You can just do fractions with regular numbers. Well, sure you can, if you understand the concept. And now we got to get into some other things because we got these things called negative exponents.
It's simple as hell.
Okay. Sorry. There you go. Watch your language, young lady. But yes, I do make it that simple. Right? That's the idea, is to keep it simple. Because if you make it hard, why? Oh, I mean, that's just ridiculous. That what we do. All right, look. All right, you know what? I think that's enough for today. What do you think?
Yeah.
I think you did a fine job.
Thank you.
Okay, so we'll come back to this and we'll play more fractions next, and we'll talk about negative exponents maybe even. We'll just do quick. Another way to write this. Another way to write this. Oops.
Yeah.
That's it. These are same.
Okay.
Okay. Well, you can write those down if you want to, but I don't care. We'll get to it next week. Did you have a fun time? That hour went by pretty fast, didn't it?
It did.
That was crazy. All right. Thank your dad for that information, and I will talk to you in a week.
Okay. By the way, Shredder was sleeping.
He went to. I see him. He's sleeping. Out or she is sleeping. Okay. Crewton Ramone's house of math.com for more.